Hello, my name is Ms. Klett. I hope you're having a wonderful day. Today we're going to be talking about minerals, and if at any point you need to pause this video, please do so. This is at your own pace. So let's begin. Minerals. Some of the essential questions to talk about. How are minerals made? How are minerals characterized? And how can you possibly identify a mineral? First off, we got to start talking about matter. Matter is anything that has volume and mass. You and me, we all have matter. The stuff that you eat has matter. And it depends on three different types of phases. They exist as one of the three, which is solid, liquid, or gas. Solid has a definite shape and definite volume. Liquid has a definite volume, but not a definite shape. And gas has neither definite shape nor volume. So like our rocks, they're going to have a definite shape and definite volume. Whereas our liquids, like our cups of water and such, they're going to have volume, but they're going to take in the shape whatever they're in. And gas has neither definite shape nor volume. Like we do not see the air molecules in our air, but we have it in here. So as you can see on our picture, we have solid that again has its own definite shape. We have our liquid that can hold the shape of whatever it's in, and then gas molecules that do not have that shape. So minerals are naturally occurring inorganic solids with an orderly crystalline structure and a chemical composition. And let's talk about that here in a little bit. But here are some examples of what type of minerals that we can see. So characteristics. We have naturally occurring, it has to happen in nature. It has to be formed by some sort of geological experience that has happened. And if it was made by man, it was made in a lab, and that is not considered a mineral. And and this is something that we can talk about at another time on the possibilities on how you can possibly figure out if you have yourself a natural geological process mineral or if it's man-made. Inorganic. They have to be inorganic, meaning that they were never once alive. So they are abiotic type materials that are found. And crystalline structures are based on like just how like our water molecules are formed. You have our oxygen uh, bonding towards hydrogen atoms because of their polarity mixtures and such. And in some ways, the structures is kind of similar, not in magnetizing ways, but however, it's basically adding into how the atoms are coming together based on the chemicals and if they're suited to be towards each other and such. They're arranged in some sort of form repetitively over and over again, and it will be slightly different to every single different type of mineral. Chemical compound again has to be made more. Most minerals are chemical compounds made of two or more elements that are coming together. So, for example, like we could talk about the quartz family. Quartz family is made of Si, which is silicon, and oxygen, which is O. And then whatever other element that combines into it can change the mineral quartz into multiple different colors. And we'll talk about how you can be identifying the different types of chemical or different types of minerals. And it definitely has to be a solid. So it has to stay solid at least at a temperature of 120 degrees Fahrenheit. If it can melt at like before 120 degrees Fahrenheit, that's the highest temperature we have gone so far on this planet Earth, then it will not be able to survive and it will not be considered a mineral. Now let's talk about the different properties of minerals and how we can be able to identify them. First things first, the easiest one that we could talk about is color. Minerals all have different types of colors. Some look very similar to others. The only difference is that, for example, quartz. Quartz is a mineral family. However, there's multiple different kinds of quartz. So like amethyst, rose gold, not rose gold, rose quartz, smoky quartz, those type of crystals or those type of minerals, they take the same things, SiO, and whatever else is added onto it, plus whatever other element is needed to make it into a different color. So color is wonderful to be able to see. However, you're going to be seeing different types of minerals that are going to have the same kind of color, but they're from a different type of family. So color is the first thing to help, but it can't be the only thing that we can use to narrow down what type of mineral we have. Another type of way in how we can identify a mineral is the color of the mineral that it is in powder form. This is called a streak. So for example, we have ourselves a darker, more darker type of mineral, which is going to leave more of a streak color. We have black here, galena, no, not galena, hematite, and it leaves different types of streak colors. Some colors are so light that you're going to have a dark porcelain plate in order to be able to do the streak test on. Every single day, you guys, if for those of you that write with pencils, you're showing off on a streak test. Galena is what's in your pencils. Okay? It's not lead like what everybody thinks it is. It's galena. And galena is one of the minerals that are used, especially, for example, pencils. So, and on the streak test, on your papers, galena gives off a dark streak. And that's how you're able to write. Luster is the description on how light reflects the surface of a mineral. Now, some are going to be metallic, which is looking like this one. It's going to have a metal shine, kind of like what your desk, chairs, and tables are looking like. But then you also have non-metallic, which is going to be like your glass, your like some of like the lighter colors like amber. We'll talk about amber in a little bit. But these are going to be like your non-metallic looking ones. So metallic is going to look like metal. Non-metallic is not going to look like metal. It's going to look anything else, like pearly white, iridescent, earthy looking, and just for some examples. So again, pearly, silky, or earth, minerals that are pure metals are said to have a metallic luster, so they're going to look like metal, whereas non-metallics are going to be looking more non-metal. Again, streaks can tell the difference between a metallic luster and a non-metallic luster. And metallic luster tends to have more of a darker streak to it than a non-metallic. Non-metallic tends to have a lighter streak color to it. Now, the hardness of a mineral is also to be determined. Galena, for example, it may look like it's strong, but it's about a hardness of a 2. You're able to scratch it with your fingernails. Diamonds, hey, most people like diamonds and everything. That is the hardest mineral that you can do. So far, there's not a whole lot of things that can, cut into it unless it's precision machinery. With that being said, talc is part of like your powder form, like parts of the powder form in baby powder. And as we go up, quartz is going to be like a level 7. And each of these levels just gets the mineral harder and harder and harder. Like it will continue getting harder. Like this is the easiest one. Talc is easy to scratch. Whereas diamond, it cannot scratch. So that being said, like how we're able to test the hardness of a mineral, first off, that we can do easily is by our fingernails. Our fingernails has a hardness of 2.5. Even those that have the acrylic nails or fake nails and such that are added on, it will still have a hardness of a 2.5. So anybody can do the scratch test on this one. Copper pennies have a hardness of 3.5. So it's a little bit harder than our nails, like that can scratch our nails. But again, this is going to tell like how strong the bonds are with the minerals. And the weaker the bonds are, again, the weaker the mineral is going to be. The stronger the bonds are in the minerals, the harder it is going to break. If you're to take a glass plate or a pocket knife, that's going to have a hardness of a 5.5. If you take a steel nail that we use for construction and everything, that's going to have a hardness of a 6.5. A masonry drill bit the higher it goes. The ones that we able to make holes into the wall and such, that's going to be an 8.5. So again, as you go up higher, it just tells us on how hard or how strong the bonds are between all the atom molecules in the mineral. So again, one object can scratch the other unless both are about the same hardness. And the Mohs hardness scale goes from 10 being the hardest and 1 being the softest. And every single person, whether you have, every single person can scratch anything with a 2 or lower, because our nails are that strong to be able to scratch 2 or lower. Breakage. And this is how the mineral breaks. Some minerals are breaking into clean cut, precision, straight, even lines, whereas others do not. And it's based on how the minerals, are like the atoms inside the minerals, arrange themselves. So cleavage is a clean break, flat, even, at least by one parallel lines. So here we have ourselves a cleavage because they are based on straight, even lines, based on how the minerals are lining up together. Fractures are uneven. So these don't have like a certain, they have a structure, but they don't have like that nice, crisp line like cleavage minerals do. Fracture minerals have some structure, be able to hold up, but it's not exactly in line. Like they're slightly all over the place, but they're still connected to make these type of minerals. And there's 3 different kinds of fractures. You got smooth curved surfaces, and it has more of a glassy feature to it. Some are break into splinters or fibers. So like if you pull it apart, it looks like as if it's fiber from the plants. Or they're going to be completely irregular, meaning like there's no rhyme or reason as to why the minerals break. All right, and that is it for today. If you have any questions, you can ask me later or ask your teacher. We will talk about more on rocks here soon, which we had to talk about minerals first in order to get the basics of rocks. Hope you have a great day.